To solve part B of this problem, how many grams of the excess reactant are left? In part A, we have already calculated the amount of liters of oxygen that will be used by the 0.5 grams of hydrogen that we already know is a limiting reactant. So let's start from there. I will do all the calculation again. We know that hydrogen is a limiting reactant, so 0.5, this is not the color. We start with 0.5 grams of hydrogen. And now we want to know how many grams of the excess reactant that we know that is oxygen are left. So I need to go from grams of hydrogen to grams of oxygen. Or I can take the liters I have in the previous problem. Let's do the first part. We have 0.5 grams of hydrogen. Then we transform this into moles. 2 grams of H2 that are 1 mole of H2. Oh, sorry, it was too big. Then I use the mole ratio. Remember that we have 2 moles of hydrogen reacting with 1 mole of oxygen. And here I can do 2 things. As the amount of oxygen I have is in liters, well, in fact I can do more than 2 things, but let's do the 2 more possible things to be done by you. As the amount of oxygen is in liters, I can do what we did in the previous problem, transform this into liters. So 1 mole of oxygen is 22.4 liters of oxygen. We already know that it was 2.8 liters. Oh, sorry. Let me show you here again. Unit cancellation. This, and we have the same that we did in the other problem. 0.5 divided by 2 again, and then multiplied by 22.4, and we have 2.8 liters of oxygen. These 2.8 liters of oxygen were used completely. So if we have 5 liters of oxygen available and we used 2.8, what remains is 5 liters of O2 minus 2.8 liters of O2. We have 2.2 liters of O2 left. These 2.2 liters will not be used because there's no more hydrogen to react with. Now we know how many liters of oxygen are left. We can go from liters of oxygen to grams of oxygen, and this will be made by using first the molar volume, 22.4 liters of oxygen. I can transform it to moles like this, 1 mole of oxygen, and then use the molar mass. Here we have 1 mole of oxygen that has a molar mass of 32 32 grams. This is one of the possibilities I have here. And this will give you, we have 2.2 times 32 divided by 22.4, and it will give you 3.14. It is not pi, but it gives you 3.14285714. So 3.14 grams of oxygen left. Okay, here cancelling units is like this, and we have grams of oxygen left because we are calculating them from the liters of oxygen that were left. Another possibility here is to make these two just one factor. If you are skilled enough to do this, you can start from the 2.2 liters of oxygen and then go directly with equivalence between 22.4 liters of oxygen, that is 1 mole, and 32 grams of oxygen, that is 1 mole, and then you will get here. Another possible way to do this is to go from the 0.5 grams of hydrogen directly to grams of oxygen. Let's do it. 0.5 grams of hydrogen. Again, first the molar mass of hydrogen. 2 grams of hydrogen is 1 mole of hydrogen. Then the mole ratio again. It is 2 moles of hydrogen that equals 1 mole of oxygen. And then here use the molar mass instead of the molar volume. We have 1 mole of oxygen that equals 32 grams of oxygen. We cancel units, and this is the grams of oxygen that will be used by the 0.5 grams of hydrogen. So it will be 0.5 divided by 2 divided by 2 times 32, and we have here 4 grams of oxygen that will be used. And then I need to transform the 5 liters of oxygen into grams to be able to make the subtraction. So I start with 5 liters of O2. I transform them into moles. 22.4 liters of O2 is 1 mole. I can go directly here for grams. We already know that 1 mole of oxygen is 32 grams. So we can save one step here. If this is confusing for you, just make what we did here. Do it in 2 steps. And then we have 5 times 32 divided by 22.4. We start a reaction with 7.14 grams of oxygen. We cancel here these units. And from this 7.14 grams of oxygen available, we have already used 4. So what we have left is 3.14 grams of oxygen. This is another possible way to do this. Okay, these are left. I expect that this will help you to clarify what to do to calculate the grams of the excess reactant here. And as you can see, there's many different procedures. Use the one that you understand best.